Could your iPhone actually run an AI model locally? What about the cheapest Mac Mini? And what exactly are you getting when you jump from an $800 computer to a $5,000 workstation to a $300,000 AI server? That's what we're going to find out. We're going to be starting with hardware you might already own, and then we're going to climb the local AI ladder all the way into ridiculous data center territory. At each level, we're going to be answering 3 questions. What models can it realistically run? What can you actually do with these models? And what happens when you push the hardware too far? And some of these devices are capable of a lot more than I expected. Before we start, there's really one technical concept you need to know before we hop in. For local AI, memory is king. Generally, bigger models require more memory. And something called quantization lets us compress those models so they take up less space. So when you hear me say a 3 billion, 8 billion, or 70 billion parameter model, just think of those as progressively larger model classes. Bigger does not automatically mean smarter, but bigger usually means harder to run. That's enough theory. Let's see how far an iPhone can get us. Level 1, iPhone 17 Pro Max. At around $1,200, this thing can actually run small language models entirely on the device. Models in roughly the 1 to 3 billion parameter range are the sweet spot. So something like Llama 3.2 3B or one of the smaller Quant models can give you a completely private AI assistant without sending every prompt to the cloud. And that's pretty impressive for something sitting in your pocket. These models aren't going to compete with the largest cloud models, but they're capable enough for things like basic chat, summarization, rewriting text, and simple assistant tasks. And because everything is running locally, your data can stay on the phone. But there is a catch. Try pushing toward larger models and you're fighting limited memory, heat, battery drainage, and the restrictions of running all of this inside of iOS. You may be able to squeeze something like a 4 billion parameter model onto it with the right setup, but at that point, we're already getting outside the phone's comfort zone. So could your iPhone run a local LLM? Absolutely. Could it replace ChatGPT running on a massive cloud server? Absolutely not. Now let's give ourselves an actual computer. Level 2, 16 gigabyte M4 Mac Mini with 512 gigabytes of storage. You're looking at roughly $800, and this is where local AI starts becoming genuinely useful instead of just impressive because it happens to run. Now we can comfortably move into the models around the 4 billion parameter range, something like Qwen 3 4B or Gemma 3 4B. These give you enough capability for summarizing documents, answering questions, basic coding assistance, classifying information, and powering simple local automations. You can also start experimenting with 7 and 8 billion parameter models. These are possible, but we're approaching the limits of the machine. You may need to close other applications, shorten the model's context window, or accept the slower performance. And this introduces an important distinction. Your SSD, or the storage device, determines how many model files you can actually store. Your memory determines how large of a model you can actually run. So buying a massive SSD storage does not suddenly turn a 16 gigabyte Mac Mini into an AI monster. At this level, you're getting a very capable beginner local AI machine for under $1,000. But once you start looking at larger reasoning and coding models, 16 gigabytes gets cramped pretty quickly. So let's double the memory and see what we can get. Level 3, 32 gigabyte M4 Mac Mini with around a terabyte of storage. Depending on the configuration, we're now at roughly $1,400, and doubling the memory opens up a surprisingly different class of models. This is where something like Qwen 3 14B and Gemma 3 12B starts becoming a comfortable target. And this is also where local AI becomes much more interesting for people doing real work. We're talking stronger coding assistance, better reasoning, document analysis, research, and more capable local automation. You can even start experimenting with models in the 20 to 30 billion parameter range when they're compressed enough. So 32 gigabytes gets you significantly further, but the really large models are still out of reach. For that, we need another jump. Now we're at the M4 Pro Mac Mini with 64 gigabytes of memory. An AI-focused configuration with around a terabyte of storage lands somewhere around $2,500. And 64 gigabytes is where things start getting serious. Instead of worrying about whether a 20 billion parameter model will fit, models in roughly the 30 billion parameter class become much more realistic. Qwen 3 32B and Gemma 3 27B. And at this point, you have a genuinely powerful personal local AI workstation sitting on a desk. And 70 billion parameter models start entering the conversation. Technically, a heavily compressed 70 billion parameter model can fit into this amount of memory, but technically fitting and actually being pleasant to use are two very different things. The important thing is that we've gone from running tiny phone models to now running models with tens of billions of parameters, and we're still only using a Mac Mini. But now we're going to change architectures completely. Level 5, RTX 5090 workstation. The GPU itself has an MSRP of roughly $2K. Once you add the processor, motherboard, power supply, cooling, RAM, storage, and everything else, a complete system could easily land between $4,000 and $6,000. But here's where this comparison gets interesting. The RTX 5090 has 32 gigabytes of dedicated VRAM. That's half the memory of the 64 gigabyte Mac Mini we just looked at. So why would you spend more money for less AI memory? Speed. Apple's unified memory architecture gives the processor and GPU access to one large shared pool of memory. NVIDIA gives the GPU its own extremely fast, dedicated memory. And when your model fits inside that VRAM, NVIDIA hardware can run it very quickly. You also get access to CUDA, which is the software ecosystem that a huge amount of AI software is built around. So the RTX 5090 doesn't necessarily unlock a dramatically larger model than the 64 gigabyte Mac. It just changes how fast you can run the models that fit. And that's an important distinction. If you want the maximum model size, memory matters enormously. If you're repeatedly generating tokens, doing code work, testing models, or building AI application, speed starts mattering a lot more. But that 32 gigabyte VRAM ceiling is still real. A standard 70 billion parameter model generally won't fit completely inside the GPU at normal 4-bit quantization. You can move parts of the model into system RAM, but once you start doing that, you give up some of the speed advantage you bought the GPU for in the first place. So the 5090 isn't simply better than the Mac, it's optimized for a different priority, and now we're about to stop making compromises around speed and memory quite as often. Level 6, M3 Ultra Max Studio. The base configuration starts at around $5,300 with 96 gigabytes of unified memory. And this is the point where 70 billion parameter models stop being an experiment and start becoming a realistic part of the system. Llama 3.170B is now a legitimate target. So is DeepSeek R1 Distill Llama 70B, and that's a major milestone. For an individual who wants a powerful local coding model, research assistant, reasoning model, or private AI environment, this is an enormous amount of capability sitting on a desk. And because Apple is giving you such a large unified memory pool, you can run models that simply won't fit into the VRAM of a single high-end consumer NVIDIA GPU. You can even experiment beyond 70 billion parameters. Models above 100 billion parameters start becoming technically possible with aggressive compression. But again, possible does not always mean ideal. At some point, generation slows down enough that you're proving the model can run instead of actually enjoying using it. The Mac Studio is essentially where personal local AI starts colliding with hardware that would have sounded like server territory only a few years ago. But there's another desktop machine built specifically for this problem. Level 7, NVIDIA DGX Spark. It costs roughly $4,700 and comes with 128 gigabytes of unified memory. And unlike the workstation we built around the RTX 5090, this system was specifically designed for AI development. NVIDIA positions it as being capable of running inference on models up to roughly 200 billion parameters. Now, that does not mean you can download any 200 billion parameter model, press a button, and expect it to fly, but the 128 gigabyte memory pool pushes us into another class. Models like Llama 4 Scout become much more realistic. You can experiment with models like Mistral Large 2, which crosses the 100 billion parameter mark, and you get that larger memory pool while staying inside of NVIDIA's software ecosystem. This is the interesting thing about the DGX Spark. It's sitting somewhere between a personal workstation and professional AI infrastructure. You could actually put this thing on a desk, but the type of models you're experimenting with are starting to look a lot less like normal desktop AI. And eventually, even 128 gigabytes isn't going to be enough because the largest open models are completely ridiculous. So let's continue going down the spectrum. Level 8 total NVIDIA H100 servers. Up until now, everything we've looked at is at least theoretically something you could put on a desk. This is about to change. An 8 GPU NVIDIA H100 server from Llama is listed at around $315,000. And that's before you start worrying about the electricity, cooling, networking, maintenance, or where you're actually going to put it. We have officially left personal computing. Each H100 is a professional data center GPU. Put 8 of them together with high-speed connections between the GPUs, massive amounts of system memory, specialized networking, and software designed to split enormous AI workloads across multiple processors. And now we can begin to use the largest open source models. Qwen 235B, A22B, roughly 235 billion total parameters. Llama 4 Maverick, roughly 400 billion total parameters. DeepSeek R1, around 671 billion parameters. DeepSeek R1 may contain hundreds of billions of total parameters, but only a fraction are active for each token. That makes the computation more manageable, but all those model weights still need to exist somewhere. And suddenly you understand why we're no longer talking about a Mac Mini. An 8 H100 system isn't designed to give one person a slightly better chatbot. This is infrastructure for organizations running enormous models, serving many users, or building AI systems that can't reasonably fit inside a normal workstation. We started this video with a model running on an iPhone. Now we have 8 data center GPUs talking to each other inside a machine that costs more than many houses. That's the local AI hardware ladder. Local AI exists on a huge spectrum. For one person, a small model running privately on a Mac Mini might be all they ever need. For someone building with larger coding or reasoning models, more memory starts to make sense. And for companies serving massive models to lots of users, this is when the data center hardware starts to become necessary. If you want more practical breakdowns of AI tools, models, agents, and automation, subscribe to the channel. I'm coming out with new videos just like this every week. Thank you for watching, and I hope to see you in the next one.